Okay. Hi, and welcome to the 9th lecture in the course Programming and Data Structures at Linnaeus University. The topic for today is generic classes. Do you know what we mean by a generic class? Kind of. A kind of a class. Well, you have used them, but you have not implemented them yet. Classes with a type parameters. You have used, for example, ArrayList and hash set and things like this. Classes that when we are creating a new object, we are instantiating, saying that this one should work with integers and things like this. So instead of implementing a class, for example, like intList, in the future we would like you to implement a generic class list, which you later on can instantiate as a list for strings or a double or students like this. So this is generic classes, classes with type parameters. It is a rather new feature in Java. It was introduced a few years ago in version 1.5. What version are we using now? 1.8. And Java is always competing with C#, so they were introducing it in the same time. C# was a few months ahead of Java, so then Java caught up. So in the next version they also come up with this feature. You have used generic classes before. Here I am creating an array list of type integer. I'm inserting here a type parameter integer, saying that this particular array list can only handle integers. And then I just move on. I'm adding integers, and when I'm removing things from the list down here, it knows that inside this one we only have integers, so I can assign it to an int variable like this. If I didn't use a generic list, this is the raw version where we can store everything. I can store everything, and I can store integers as well. So here I am adding a number of integers, but the major difference is that when I'm picking things out here, since this one is a raw version, the compiler don't know what comes out here, so we need to cast it into an integer down here. Do you see the difference? In this one we have specified that everything inside it is an integer, so when we are picking it out, we know that it's an integer. Here we have a raw version, we don't know what it is, so we have to convert it into an integer here. What is the advantage and disadvantage of these two approaches here? Assume that I had an array list of this type, and for some reason inside my code I decided to add a string to it. When should I discover the mistake? At what point? What? At compile time. If you try to add something to this one which is not an integer, the compiler will discover that this is a mistake. You cannot add a string to this particular list. If I was using this approach and I did the same mistake, I was adding a string to it, when should I discover it? At runtime, when I'm picking them out and I try to convert it to an integer like this, I would discover the error. So mostly generic classes errors are discovered at compile time, and if you're not using the raw version, you're often ending up in class cast exception. You discover them at runtime. And we prefer to find them at compile time. You are coding here and you're immediately finding that something is wrong. In this case, it must show up much, much later. When you have, in the worst case, you have done your product and shipped it to the customer, and the customer is finding out the error. So if you can have the option of using a generic version and a non-generic version, always use the generic version. It's better code quality in that way. I think this was the one that I said. Okay, so you have used generics and you understand why to use generics. Implementing generics, it looks something like this. We are creating a new class here, it's called just A, but we insert a type parameter. And this one could be integer, string, or whatever. When we later on are instantiating it, it can be whatever type. And then inside here, we are using T as a replacement for whatever type we are using. So In the case we are using a class of integers, think of it as we have int here, int here, int here, and int here. What is the problem with this approach? The problem is that any code you are writing here and here must work for any object. You cannot assume that it's a string, you cannot assume that it's an integer. Basically, you can only use methods that are available in the object class. You know that all classes we are using are inheriting from object. The object class comes with a number of methods. They are always available. So in a generic class that looks like this, you can only assume that the most general case, and the most general case is an object of class object. What methods do we have in the object class? Equals, hash code, compare to, no, to string. Basically, these are the ones that we can expect. I will show later on how to I will show later on how to make it a bit different. So this is a very simple example. It's a generic value, t. I have one field here that keeps the value. I have a constructor here. Whatever I'm adding here, I'm assigning it to this one. Set value, we can update the value using this tool. We can ask it, give me your current value. We are returning this one of type t and type t. And we are overriding the toString methods to make something like this. This one works for all classes. I'm only using the toString method here. Apart from that, I'm not using anything at all. So I can later on create a generic value of type integer and give it the value 7. I can change the value and I can print it using the toString and the getValue methods like this. The same thing, I can do it for a string. I create a generic value of type string with this one as an input, and I can print things like this. It works for any type, not just for integer, not just for strings, it works for any type, since we are only relying on methods that are available in the object class, and they are always available for everyone. Any questions? Here I'm overriding the equals method. So in my generic value, this is one additional method that I didn't show in the previous slide. I'm overriding the equals method in the object class. I check if it is an instance of generic value, then I convert it and then I compare it. Why don't I have t here? In the generic class, when we are comparing our generic value with another generic value. Well, if I were changing this one to t here, I would not override the previous one. You can only override a method if you have the same signature. So in that case, if you try to use t here, you cannot use override here. The compiler will say that there is no such class to override. Yeah. What?
Is it possible to overload in the sense that you write equals?
Yeah, you can have your equals t here, but in that case you are not overriding the default behavior. You are adding one more method, so you are overloading it, not overriding it in that case. Yeah. So. In general, generic classes are classes with type parameters, one or more. They look like this. T is just a parameter. You could call it E or K or whatever. E and T are commonly used. But any uppercase letter will do according to the naming conventions in Java. But it's just the name of a variable, like a function of x. You can change a function of t. It's the same function, basically. Must work for all parameter types t. So in this case, expect only class object properties. Equals, hash code, toString, and clone. They are available for you to play around with. I will show later on that we can the types can be limited. We are saying that we can have a generic class saying that T, but it must be of a certain type. In that case, we are limiting the possible values for T, but we are extending the possible methods to use later on. Generic methods, this is rather rare. I never use generic methods, but you can, rather than having a generic class where we have a type parameter, you can have a type parameter only on a certain method. Then you are inserting the type parameter here before the return value. It is not the generic class, but this particular method is generic. It can handle any type of array. The same here. We have a method find a minimum in a certain array. Here I have the type parameter is, it will return an E value in an E, you look for it in an E array. Here I am saying that it can be any E as long as it extends comparable. Here I have limited the number of possible types. It can be any type as long as it implements the comparable interface. That means that apart from the, in addition to the object class methods, I can also use compare to. Since any type that we are using, it can be any type as long as it implements this one. So I'm limiting the set of possible types, but in the same way I'm extending the range of possible methods for me to use. Do you understand this idea? So up here I could have said T extends comparable, iterable, whatever, some interface is it often. Then I can start to use all the methods that are defined in this interface down here, but I can only create new objects that fulfills these properties. Yeah?
Extend or implement?
You are writing it here extends. The syntax is to say that we are extending, but the type that you are instantiating it with is often implementing the comparable interface, because it's comparable, but it should be extends here. Okay, do you understand the idea of limiting the scope and increasing the number of available methods? Yeah. So use this approach if you are sure that you have a generic class, but it should only work in a certain, for certain types. Then you are defining an interface for these certain types, and you're using, saying that, okay, we are limiting the generic type to anything that implements this particular interface. So here, as an example, I'm creating a string of arrays, giving a number of strings here, and then I apply it on the print method. It is a generic method, but when you're using it, you don't have to specify that I'm using a specific version. The compiler and the Java virtual machine will, at runtime and or at compile time, deduce that, well, it's strings that we are working with in this particular case. So they are rather rare, the generic methods, but this approach is rather common, but then for classes rather than methods. I think this was a summary of what I just said. So, important, constraining type parameters. You do it by extending often an interface. We are limiting the possible number of types that we can use by using this approach, saying that it can be any type as long as it implements the comparable interface. By doing so, we are increasing the number of available methods that we can use inside. I will show a slightly longer example, a generic list. This is the corresponding non-generic interface. In general, when you are new to generics, my suggestion is that you are implementing a non-generic version of what you're interested in. If you're interested in a generic list, I suggest that you implement a list for integers. When you have that one up and running, you are converting it method by method to to the generic version. It's the simplest case to get started. I have here a list, an interface that describes a list of integers. It extends the iterable for integers. I have a number of methods here: add, contain, get, size to string, add all. You can add anything that implements this interface to it. The corresponding generic interface is to replace int everywhere with the type parameter t. Later on, I can have a class generic list of type integer or string. So take this one as a starting point, convert it to generic interface, and everywhere where it's int, you are replacing it by t. Is this an error? No. The size is not the generic parameter here. It is always an integer. So you cannot use replace in your text or something like this. You must keep a part of your brain working when you're converting it from non-generic to generic anyway. But anyway, it's rather straightforward given a non-generic version to come up with a generic part. We are implementing it. This is my generic array list that implements the generic interface. I keep track of the current size. I store my values in a generic array. If I have integers here, it will be an int array. If it's strings here, it will be a string array. However, notice you cannot create a generic array. So you are creating an object array, cast it to a generic array down here. It's a bit strange, but you cannot create a new object of generic type, a new array object of generic type. The variable later on, when you try to assign something here, the type checking that takes place is against this one. We are trying to add a value to this array up here, and it must be of type t, otherwise we cannot fit it into this one. So you recognize this approach. I've shown it many times before. We are adding something to our array. This time we are adding something of type t, and we are assigning it to our t array. We are checking if it's time to increase the size, and if it is full, then we are resizing it. And down here, I'm creating a new object array of twice the size, cast it into a t array, copy all values from the old array to the new array, and update this one with a new array which is twice as long. Do you recognize this idea? Basically, I have replaced int by t at all places. The method add all that looks like this. What can be added to this one? Well, all data structures in Java are iterable. You can ask them for an iterator. You can use the short for statement for them. So all the data structures in Java is fulfilling this criteria. They are iterable. That means to this method add all, you can add any collection class in the Java library. So, for example, it can look something like this. I have my generic array list here of type string. I am creating an ordinary array list of type string, and I'm adding a number of strings to this one. Then I can add this string to this string using the add all method here. The array list of type string here implements the iterable string interface. So this parameter iterable t here, it means you can add any of Java's collection classes to it, because all of them are implementing the iterable interface, and you can add anything that implements the iterable interface. Do you understand how it works? It's very simple. Add all. The input here will be a data structure of the type parameter t. All I have to do is to iterate over it and add it to it using the add method that I showed in the previous slides. I'm just iterating over whatever comes in here, pick out the element, and use the add method this one to add them. In many cases, it is easy. You have your non-generic version, the contains method here, and you would like to convert it to a generic version. Here I have the contains method for integers. We are asking the object, do you contain this particular integer? We are iterating over all our values, and if the values, if one of the values are the same as this one, then we are returning true. In the non-generic version, it looks almost the same. You are replacing int with t here, and you must remember that since this is an arbitrary object, we cannot use this approach. We should use the equals method instead. If I apply this operator on objects, what is the question I'm asking them? If it's the same object, not if they have the same value or something like this. It's the same object. Yeah, do you understand the idea? So once again, when new to generics, start by implementing a non-generic version. It's the simplest case. And then take a look at the methods one at a time and just convert it from int to t. Slightly more complicated case. We're saying that our list implements the iterable interface. This is my non-generic integer version of it. My array int list implements this interface. I do it by having this method is required by the iterable interface. I have a method called iterator that returns an iterator over integers. I implement it by creating a new object of my own list iterator here. The list iterator is something that implements this interface, and it has the next, the has next, and the remove method, which is not optional. Yeah? This is an inner class. In most cases, this is an inner class in the class array int list here. The corresponding version for the generic class looks like this. I have my class generic array list that implements this interface, and this interface is implemented the iterable interface. So I need a method like this, something that returns an iterator over t objects in this case. I do the same approach. I create a new list iterator of value t, and here I have my inner class. You must realize that this is one class containing another class. You should have a different type parameter here. This is in some way, this one is independent from this one. So you should not use this x here. It's the same x everywhere, but it's not necessarily the same as this t1 up here. So we are not using the same type t as the enclosing class generic array list here. Otherwise, it is a generic version of the one that I showed you previously. We are defining it here using the type parameter x. We are using it here using the type parameter t. Yeah. That was basically it. You should read chapter 16 in the book by Horstman. Sun has also a very good tutorial when it comes to generics. When I run into trouble, this is where I look. It's a good one. Also, I have given you the generic array list example as a part of the lecture material for this course. I think taking a look at the generic list, try to understand all details, is a very good starting point before you start to do your own programming. I have published the 4th assignment. We want you to implement a generic linked queue. This one was the same as you did in the 2nd assignment. So you have a non-generic version of this one. All we want you to do is to convert your previous linked queue into a generic version of it. In assignment 2, you were asked to come up with a JUnit test for the, or was it an integer queue? Yeah. You should update the corresponding JUnit to handle generic version of it. Remember that when you are testing a generic class, you cannot only test it with integers. You should at least use 2 type parameters to make sure that it's not only working for integers. Some of you implemented a generic array-based queue, the circular queue. It was a VG exercise in assignment 2. We want you to do a generic version of it here. So the VG exercise here is to make a generic version of the VG exercise in assignment 2. Of course, feel free to use your own assignment 2 solution. Self-plagiarism is not a major problem. My hint is to start by handling any comments from the teaching assistants. If the teaching assistants told you that, well, your linked queue was good, but it could be improved in this way, start by improving the non-generic version before you're converting it to the generic version. But in general, this one shouldn't be that difficult. I think it looks strange, the generic classes. It's a bit annoying, this T parameter, but just think of it as anything. And in this case, since we have not restricted it in any way, just look at the code and think it should work for any object. That means you can only rely on things that are available in the object class. So that's the reason why we are going from this one to this one over here. We are realizing that it can be anything, and this one will not work as we expect for any type of object, but this one will hopefully work as it should. I think it's a rather straightforward, the first exercises. Questions related to generics? Good. Have you submitted the third assignment? Was it time consuming? No. My answer is no. And your answer is? It was not as time consuming as the second one, wasn't it? No. And I think also the fourth assignment is comparable to the third assignment when it comes to workload. Anyway, we have another lecture on Wednesday. See you then. Bye.